All right, I'm going to go over the test, summative topics 3 through 7 for you and let you know how I got the answers I got and kind of see where we made some of our mistakes. So the first question, says determine the pattern and then name the next two terms in the sequence. That was pretty easy. So we had, we had 9, 11, 15, 21, 29. So we look at this pattern and we see, well, what's happening here in the sequence? Can we find a pattern, And we look and we see, well, what happens between 9 and 11? We can see between 9 and 11, you're adding 2. All right, we can see between 11 and 15, you're adding 4. Between 15 and 21, you're adding 6. Between 21 and 29, you're adding 8. All right. So now you can see 2, 4, 6, 8 is the pattern. So what comes next in those patterns? 2, 4, 6, 8, 10, 12, so on and so on. We're only looking for the next two top numbers here. Added by 2, added by 4, added by 6, added by 8, added by 10. So we take the last number, which is 29, and add 10. So it becomes 39. All right, using the same situation, we take 39, the next number, and add 12. That becomes 51. So the next two terms in the sequence we were looking for was 39 and 51. All right, the next problem was the same, but a little more difficult. Same situation, determine the pattern and name the next two numbers in the sequence. So you have 5, 15, 45, and 135. So now that we have these numbers, we can see another pattern. What can we find out? Well, between 5 and 10, 5 and 15, they're adding 10. Between 15 and 45, they're adding 30. 45 to 135, they're adding 90. That's not really much of a pattern, is it? So I already established that I'm not seeing too many familiar things here between each of these numbers. All right, one's going up from 10 to 30 to 90. Not really a great pattern. So let's get rid of that. And let's try and determine other ways that we can get from the first number to the second number. Well, between 5 and 15, we tried adding 10, didn't get there. So how else can 5 get to 15? Well, we can multiply something by 5 to get to 15. Multiply 3. That gives me 15. Let's see if that's a pattern. I multiply this by 3. I get 45. I multiply 45 by 3. I get 135. So I've seen a pattern now. That's great. Now let's keep the pattern going. Multiply 135 by 3 and we get 405. Multiply 405 by 3 and we get, using a calculator, 1,215. Those are the two numbers that we want next in our pattern, term, and sequence. So it's not always going to be adding. Sometimes it's developing the next mathematical way to get to the numbers. It's not always adding, sometimes it's going to be multiplication. All right, let's try now maybe possibly doing some segment addition postulate. Number 3 says solve for x. So we have to find out what the value of x is. So we have the line J, L, and there's a K here as well. It tells me the entire line, JL, is equal to 15. Cool, so we know that JL is 15. Then it tells me JK and KL, their value. So JK's value is x plus 2. KL has a value of negative 5 plus x. Okay, so I know from segment addition postulate that if I take JK and add it to KL, it equals the whole thing, which is JL. So this value right here plus that value right here will give me the whole value, which is 15. So I write that as an equation. My equation is x plus 2 minus 5 plus x equals 15. All right, so I have some like terms here. We went over this last week. I have an x and an x. All right, they're like because they're both variables. So I can add them together. An x plus an x is 2x. And then I have 2 minus 5. All right, 2 minus 5. And the calculator gives me negative 3 equals 15. Now I want to have my x by itself, so I have to get rid of this 3. I do that by adding 3 to both sides. They cancel out. I have 2x equals 18. I want that x to be by itself again. So instead of moving it this time, I have to split it in half. I have to divide it. So I divide by the number 2, and x equals 9. Pretty easy. Number 4 is a little more difficult. Right on the board again. Number 4 says that F, G, H. All right, so it says the whole thing, F, G, H, the entire line is equal to 4x. F, G is equal to 3x, and GH is equal to 3. All right, so set up the exact same way I did before. FG, this value, plus GH, that value, equals the whole thing, which is 4x, that value. So I set up my equation. 3x plus 3 equals 4x. All right, now I have an x on both sides of the equation. So I want to take, more than likely, my small x, which is 3x, and get it over here. How do I do that? I subtract it from both sides. Remember, I'm not splitting the x up yet. I'm just taking the whole term, 3x, and moving it over here. Drop down my 3. I have 4x minus 3x. That just gives me a plain regular x. So x equals 3, number 4. Not too bad, not too bad. All right, number 5 and 6 deals with midpoint. Midpoint's relatively easy when you have 2 points, and I gave you two coordinates for each problem. At that point, you just plug them into the formula, and you see what you get. Use a different marker, because this one is dying on me here. Okay. I have the midpoints. It says find the midpoints of the line segment with the endpoints 5, 7, -3, and 9. So I have the endpoints, need the midpoints. So I have 5 and 7, -3, 9. All right, so we have to first establish what the midpoint formula is. That'll help us out. Midpoint formula is x1 plus x2 over 2. x1 plus x2 over 2 for the x values. And for the y values, it's y1, plus y2 over 2. I have that. All right, but which are my x1s and my x2s? Which are my y1s and my y2s? All right, remember, in a coordinate pair, the x's always comes first, and then the y comes. So now we can make this one our x1, y1, x2, y2. It's important because some people messed up these numbers. Remember, if it's in a parenthesis and there are coordinates, the first one's always the x, second one's always the y. It does not matter here which ones are 2's and 1's. It does not matter because it will give you the same answer. So let's plug into my equation now. I have x1, which is 5, plus negative 3 over 2. My y values, I have y1, which is 7 plus 9 over 2. All right, let's see what they give me for my x's. 5 plus negative 3. It's just like saying 5 minus 3. 5 minus 3 is 2.